Hello and welcome back to PA Academy. So in today's video, we are going to be looking at the concept of Jacobian iteration. So these are one of the methods of solving linear equation. So if you have been following this lecture series on solutions to linear equation, you see that in the past we've looked at the different methods. We've looked at Gauss-Seidel, we've looked at Cholesky, which is the early decomposition method, and then we've also looked at the Gauss elimination method itself. So now I want to look at the Jacobian iteration. Okay, so before we get into the video, if you are new to the channel or you are yet to subscribe, kindly go ahead right now, click on that subscribe button. So I want you to do that right now. So just look for that subscribe button on your screen. Okay, depending on the device you are using, but just below it or to the right of your screen or just below the video, you see the option to subscribe. So just go ahead right now and click on that subscribe. All right, so thank you very much if you have just done that. All right, now so let's proceed with the video. So now we are looking at the concept of Jacobian iteration method of solving linear equation. Now in the previous video, we looked at the Gauss-Seidel iteration. All right, now the Gauss-Seidel iteration is quite similar to the Jacobian, just some few things you need to take note so that you can be able to differentiate them and how to apply them. So for us to explain the Jacobian, we are going to be using the same example we used in the previous video on Gauss-Seidel iteration method. All right, so if you watch that video, you see this was the question we used, and that's what you can see. You see it here, that solve the system of linear equation using Gauss-Seidel iteration. Okay, so you can see it right here, but now I want to use Jacobian. All right, so like I said, there are some similarities in between the both of them, so I'm going to walk you through and then to the point where they are now different. Okay, just in case you missed this video, just check the video before this. All right, you are going to find this particular video on Gauss-Seidel where we worked on this example. All right, so now let's look at this example here. So we have this here. This is our equation 1. We take this to be our equation 2, and we take this to be our equation 3. So if you are given a question like this and you're asked to use the Jacobian, so this is what we are doing right now. So from what we did in the previous video, we resolve it in matrix form. So like you can see here, so we have our 10 minus, so this is the same thing as 10. The coefficient of x here is 10, and that's why you are seeing 10 here. The coefficient of y is minus 1, that's why you are seeing minus 1 here. So that is how we came about this right here. And then we have our xyz column matrix, and then these values here, this is 13, this is the 13 here, this is 36, this is 36 here. All right, so that is how that. Now one thing you also need to do is to make this diagonal to be 0. That's this diagonal right here, to make it 0. And in doing that, if we make the diagonal 0, all right, so another thing you need to do is to divide the rows, okay, by whatever values that you have in for this part here. This is 10, so that's why you're having 1 over 10 here, 1 over 10, and then you give it the inverse of the sign. Like you can see here, we have here to be minus 1, so here it becomes ordinary plus 1, here minus comes plus, and then here that is plus 1, it becomes minus. All right, so all of these I've explained it in the previous part, and this is part of the solution to the question. If you have to use Jacobian iteration, I'll still get to the point where the system will be different. Okay, now for this part, now you can equal it to c, so you can see, you say, okay, let this be c. Also you divide this by 10 because this is 10 that was here, so it becomes 1.3. now you have to take note that it's not always 10, it could be any number. Okay, but because we are having it to be 10 right here, so I think it makes it more easier. All right, so it could be any number outside, just any number, but the steps are the same thing. All right, so up to this point here is the same process when you are working with Jacobian and Gauss-Seidel iteration method. Okay, so moving from here is where the difference starts from. All right, so from the iteration itself is where the difference is. So let's get started. So once you have done with all of those parts, so the next thing now, I want to start the iteration itself. All right, so for our first iteration, so for the first iteration now, so that means our x1, okay, let me first of all write, before I even indicate that, so let me write out the initial iteration that was given in the question. Okay, so we have it x1 of 0 is equals to 1, x2 of 0 equals to 1, then x3 of 0 equals to 1. All right, so the next thing now, let's indicate that for the first iteration, so for the first iteration now, so it's going to be for that of x1, so of 1, so remember it to be b1 1x1 plus b12 x2. Please, I will encourage you, if you have not watched the previous one on consider, to please do so. Then b13 x3 plus c1. Okay, so for this now, our b11 is 0. Okay, let me just go back and explain that in case you have forgotten or you've not watched the previous example. So that was why I have it at the top. You can see b11, this is b12, this is b13, and then this is b21, b22. Just if your knowledge of matrix will be of help right here. Okay, so you can see our b11 is 0, this our b12 is 1 over 10, which is 0.1. okay, so that is how we came about those values. If you look at this, this is b32, which is 1 over 10, and it's the same thing as 0.1. okay, so just take note of those values. Okay, so our b11 is 0, so that will be 0 times our x1, which is given, okay, in the question, then plus b12. Our b12 is also 0.1, so that will be 0.1 times our x2, this is it here, times 1, plus b13, which is 0.1 times 1, plus then our c1 is 1.3. Again, let me show you. Okay, so just to make sure you don't get confused, you can see this is our c1 here, this is it right here, 1.3, and that's why I have c1 at the side. Okay, so when we get to c2, this is our c2, which is 3.6, and this is our c3, which is 3.5. all right, so let's move forward. So if you should simplify this now, we are going to be getting 1.5. okay, because this is going to be 0, this is going to be 0.1, 0.1, and 1.3, and that will give us 1.5. okay, so that means our x1 of 1 is x1 of 1 is 1.5. Now let's go to x2. Now this is where the difference starts from. Okay, x2 of 1 is still going to be b21 x1 plus b22 x2 plus b23 x3 plus c2. all right, now our b21 is minus 0.1. now our x1, okay, now in the previous one that we did under this procedure, our x1 was taken to be 1.5, which is the new value. But this time around, your x1, either you are looking for x2, x3, x2, x3, or x1, will maintain this one. okay, and I'll tell you when you are going to change it. So this is going to be times 1. Remember when we did Gaussian, it was because we already have a new value for our x1, we are going to be 1.5, you are going to bring in 1.5 here. No, but you are going to maintain the initial one. So then plus b22 is also minus b22 is 0. okay, so I can just ignore this, okay, and move to b23. b23 is minus 0.1 times x3. Our x3 is 1, then plus our c2, which is 3.6. okay, so if you do this correctly, you are going to be getting 3.4. all right, so you can see that this answer for our x2 of 1 is going to be different from when we use Gaussian iteration. So this is going to be x2 of 1. So let's do that of 3. So for x, remember we are still doing the first iteration, so x3 is going to be b31 x1 plus b32 x2 plus b33 x3, then plus c3. okay, so our b31 is 0.1 times, then our x1 will still maintain 1, plus b32 is also 0.1 times our x2. Now you are not going to be using this 3.4. okay, so you are still going to go back and use the 1 times 1. So that's the difference between this and that of the Jacobian. Then b33 is 0, so with that everything here will be 0, so there's no need for me to write it. So I'll just go to plus c3, which is 3.5. okay, which will give us 3.7. all right, so with this now we can write out our value for our x1 of 1 to be 1.5. our x2 will be 3.4, and that of x3 will be 3.7. okay, all right, so now we've done the first iteration, so now let's go ahead and do the second iteration. Guys, if you are finding value in this video, please give the video a thumbs up. okay, so sorry, the second iteration rather. So we are going to be having, so let's say for second iteration. okay, so for second iteration now we are going to be having x1 of 2. Now there's also another thing you need to take note in this second one. is equals to b11 x1 plus b12 x2 plus b13 x3 plus c1. So in putting in these values now, we already know our b11 to be 0.1. I mean, our b11 rather is 0. So since it is 0, we can just ignore this because it will give us 0. So let's move to b12. Our b12 is 0.1. So then our x2 will now be this new value. All right, so this is the new value for our x2. All right, so this is the only time the value for your x1, x2, or x3 will change. Okay, because we already have a new value here. But if you are solving it and you are getting a new value from your x1, and then you are not going to use it in the subsequent, maybe your new value for x1, you are not going to use it when calculating for x2. I hope that makes sense. All right, so b12 x2 now will be 3.4. Okay, then plus b13 is also 0.1, so that will be 0.1 times our x3, which is this 3.7, okay, plus c1 1.3. okay, so if you do this correctly, you're going to be getting 2.01. okay, so now let's do for x2. So it's going to be b21 x1 plus b22 x2 plus b23 x3 plus c2. Okay, so let's put in this value. Our b21 is minus 0.1 times 1.5. okay, then our b22 is 0, so we can just ignore it because it's going to give us 0. So let's move to b23. So our b232 is also minus 0.1, so then times our x3. okay, so our x3 is 3.7. okay, so that's 3.7, then plus our c2, which is 3.6. again, you will notice that for our x1 here, we didn't use 2.01. Sure you get. So what we used was this value. All right, so you need to take notes. So that's the difference. If we were doing Gauss seidel iteration where we have our x1, since we already have a new value for x1, we'll just use 2.01. But for this, no, we are maintaining this our new 1.5 here that we got after our first iteration. So basically, that's the major difference between the Jacobian and the Gauss seidel. So you need to take note of that. So if you should do this correctly, you are going to be getting 3.08. all right, so let's move to the x3 of 2. So that will be b31 x1 plus b32 x2 plus b33 x3 plus c3. all right, so let's put in the value. So our b31 is 0.1, so that's 0.1 times our x1 again, which is 1.5. take note. Then our b32 is also 0.1 times x2. Our x2, let's see again, our x2 is 3.4. so don't make the mistake of using 3.08, okay, because we are dealing with Jacobian right now. So that will be times 3.4, then plus our c3 is 2.5. all right, sorry, 3.5 rather, not 2.5. okay, so if you do all of this correctly, you are going to be getting 3.99. all right, so with this now we are done with the second iteration. Now with the knowledge you have in the first iteration, in us calculating the second iteration, I want you to just test your knowledge. Go ahead and pause the video, try to get the third iteration. Remember, we are asked to do 3 iterations, so this is the last iteration we are going to be doing. But just to test your understanding with all of the things that I've been sharing or that you've been watching now, so you can just pause the video, do your third iteration, take note of your answer. You can just put it in the comment section, and then let's see if we are going to arrive at the same answer. okay, so guys, if you are finding value, please give the video a thumbs up. okay, and don't forget, if you have yet to subscribe, please go ahead right now, click on that subscribe button to subscribe. All right, so before we go to, let me just write this out. So that means our x1 for the second iteration, we got it to be 2.01. so our x2 for the second iteration, we got it to be 3.08. our x3 for the second iteration, yeah, we got it to be 3.99. all right, so now we can go to our third iteration. So let's say for third iteration, so we start the process again. So that'll be x1 for the third iteration, so that'll be b11 x1 plus b12 x2 plus b13 then plus c1. okay, so let's put in the values. that will be 0.1 times 3.08, which is our new sorry, not 3.08, 2.01. That should be a mistake there. So 2.01, 2.01, okay. Okay, so let me just explain this, right? So our B11, this B11 is actually 0. Okay, so if since it's 0, everything will be 0. So we are moving to B12 straight up. Okay, so in moving to B12, the value for our B12 is 0.1. So that will be 0.1 times our x2, which is 3.08. Okay, so I was correct earlier, but I was working for this. Okay, so that will be times 3.08, then plus 312. Now B312 rather, we have it also to be 0.1, and then our x3 is 3.99. Okay, then our plus C1, which is 1.3. So if you do this correctly, we are going to be getting our answer to be 2.007. All right, so that's for our x1. So let's go to our x2 for in the third iteration again. So by now you should be familiar with this: b21 x1 plus b22 x2 plus b23 x3. Okay, all right, so now so if you should put in all of this now, so our b21, that will be minus 0.1 times 2.08. Okay, our 2.0 sorry, 2.01 rather. Okay, so I'll be skipping this because this is 0, so I'll go to b23, okay, which is plus minus 0.1 times 3.99 plus 1.6. Okay, so in doing this, I'm going to be getting 0.993. Okay, so x2, so for now, for x3, for the third iteration, this is going to be the last one. So I'm just keeping writing out this. Okay, so let me just solve it straight away. So we are going to be using, remember that for b33 is going to be 0, so we are going to be using b12 and b22. So that's going to be 0.1 times 2.01 as b31 x1, then plus b32 x2. So that's going to be, so if you are following now, you already understand what I'm saying, times 3.08. Okay, then plus our c3, which is 3.5. So if you do this correctly, you're going to be getting 4.009. So with this now, we've been able to get the answer, okay, to this. So we can conclude that our x1 is equals to, so the x1 of 3 is equals to 2 points. What did we get for our x1 during the third iteration? 2.007. Okay, is equals to 2.007. Our x2 during the third iteration, we got that to be 0.993, 0.993, and then our x3 during the third iteration, we got that to be, which is this 4.009, 4.009, and this is the answer. So depending on how you taught, you can just take this is our x to 2.007, then the y will be 0.993, and then the z is 4.009. All right, so that is it on the Jacobian method. So I hope you find value, and if you have any question or any doubts, let me know in the comment section. So guys, thank you very much for watching. In the next video, we are going to be looking at another concept, which is the pivotal condensation, so make sure you don't miss that. All right, so thank you very much for watching. My name is Prosper, and I'll see you all in the next video. Bye for now.